Hello everybody and welcome to your video notes on Learning Target 8.5, which is all about circuit calculations. These video notes are going to focus on the basic level, and this is going to be the second part of your basic level notes when we're going to cover parallel circuit calculations. So here we go. Alright, so just like before, in the first part when we talked about the series calculations, we're going to be doing this by constructing an RIV table, where the R stands for resistance, I stands for current, and V stands for voltage. And it looks just like this. It has an R and I, a V at the top. We've got all of our boxes and we've got the totals down at the bottom. And there we go. I put up a series circuit before, but this is a parallel one because this one's all about parallel calculations. So, RIV tables for parallel circuits. Got our table, totals, just like before. So here's what's going to be the same as in series. Whenever we know two values in a row, we can find the third using Ohm's law. Each resistor gets its own row. So the 2 ohm resistor, or it's the light bulb, but we can treat it like it's a resistor, that will get its own row, and the same for the 4 ohm resistor. The battery is the total voltage. So right here, that's 12 volts. That's what goes down at the bottom. And then the totals are going to represent the total amount of current or voltage or resistance for the circuit. So the thing that is different from series is that parallel circuits, remember, the current splits. So it's just like you're going down the highway and there are 2 different pathways to go through a toll booth. The traffic goes through faster. And remember, the traffic flow is like the electricity flow. So you end up with more current here. And the current can be different, but the voltage is going to be the same, okay, because it's really, that's just how it works. So, and then one thing I didn't write on here is that the calculating the total resistance is going to be different than it was for in series, because for series, you just added them all up, right? But that is not the case for this time because we're going to have to use that fun equation that we talked about on the approaching notes. So I'm going to switch over to show you how to go over this calculation. Alrighty, so here we go. So everything's still the same that's on my screen as it was before, but I just may have rearranged it just a little bit. So again, just a reminder, this is Learning Target 8.5. Oops. Got the white marker on. Switch over to this guy. This is 8.5, basic level part 2 is all about parallel circuits. So one thing that if you have not highlighted or underlined or circled, it's this part right here, but voltage drop is the same for all resistors. That's a big idea. Okay, maybe put a little smiley face next to it, whatever. But make sure that part is highlighted or noticeable in your notebook, because that's the main difference between parallel and series circuit calculations. Also, the resistance is calculated differently. Okay. Alright, so let's get started. So I'm going to put my 2 ohm resistor first and my 4 ohm resistor second. Doesn't really matter which order you do it in, but that's what I did. And then if this were series, we just add these together and get our answer. But if you remember from the approaching notes, that's not how this works. The total resistance ends up being less according to this equation. 1 over the total resistance for a parallel circuit equals 1 over, I'm going to say 2 plus 1 over 4. And we'd keep adding more if there were more resistors, but there was only 2. So this is what we end up with. And so we just convert these to decimals. So I end up with, let's just zoom in here. Easier to see. end up with 0.5 plus 0.25, and then once you add those together, you get 0.75 equals 1 over RP. Then, make this a little bit thinner. Let's maybe come over here. So I've got my 1 over RP for my total parallel resistance equals 0.75. Do a little bit of algebra. I end up multiplying both sides by RP. And then we divide both sides by 0.75. I end up with the following. I got 1.3 repeating. I'm just going to round that to 1.333, and that would be ohms. That would be my total amount of resistance for this circuit. And the thing that you should notice is that this is less than 2 and 4, because our total resistance ends up being less than all of our resistors in the circuit. Okay? And then the other thing that we can get from our circuit diagram is the total voltage. It's 12 volts. So now we know two things and we can find the third. So here we go. So the total current then we'd find with Ohm's law. And we get, in order to find this, I equals V over R. Should have that equation written down, maybe tattooed on your arm, but for sure on your reference sheet. So we got 12 volts divided by the 1.333 ohms, and we end up with something really close to 9 amps. Okay, now this is where you got to take a moment and pause for a second, because if we were doing a series calculation, we'd say, oh, all the current is the same, so then we'd say it was 9 for everybody. But that's not true, right? Remember, voltage drop is the same for all resistors when we're in parallel, okay? Cannot forget that. So we got to make sure that we keep our series and parallel circuits separate. So, this one ends up being the same for all of them. So they all have 12 volts of potential. So now we're going to use our I equals V over R equation. So I am going to do 12 divided by 2, and it gets me 6 amps. And then I'm going to do 12 divided by 4, and that gets me my 3 amps. Okay, and so now to double check, we can double check by adding up the current, just like how in the series one we added up all the voltages. So we end up with 6 plus 3, and that equals 9, and that tells us that we did it correct. Okay, so to review, we did everything the same except as series, except we calculated our total current a little bit differently, or our total resistance, sorry, misspoke there, by doing our fun fancy equation. And then we found our total current just the same as before with Ohm's law, but then we said that all the voltages were the same, because that's true for parallel circuits, and then we use Ohm's law to get our currents, and then we double checked by adding up all the current this time rather than adding up all the voltages. Okay, so here we go. Here's another one, and I'm going to start by, so you're going to try doing this one on your own, and so here is what the table for this one is going to look like. Okay, so got my RFE table, and this one I drew by hand because that's what you're doing, and I put 10 and 40 in there. Again, it doesn't matter the order, and then I put my 9 volts down here at the bottom because that's where I know where to start. So go ahead and pause the video, and I will explain how I got my answers here in just a little bit. So just waiting to make sure you can get it paused. Try doing this one on your own, and the answers are coming up here very shortly. Alrighty, so here is what my final table looks like. So I started off by finding my total resistance, and I got 8 ohms. And I did that by doing this equation here, 1 over RP equals 1 over 10 plus 1 over 40. I changed those to decimals, and I got 0.1 plus 0.025. Added those together, and I got 0.125. After I did my algebra, I got 0.8 as my answer. And again, you'd multiply both sides by RP, and then divide by 0.125. Or you may have caught on by now that you could just do 1 divided by 0.125, and that's how you get your answer too. Anyway, that's how I got my 8 ohms here. And then, since I knew my 9 volts, 8 ohms, any two things gets you the third. So I found that 9 divided by 8 gets me 1.125 amps. And then I'm just going to save for later for my double checking over here at the end. And then I remembered that voltage is the same for everything for a parallel circuit. So 9 volts across the board, and then I used that to find my currents for each resistor. So 9 volts divided by 10 ohms gets me 0.9 amps, and then 9 volts divided by the 40 ohms, that gets me 0.225 amps. Oh, naked number. Close your eyes, kids. It's indecent. Oh, so much better. Whew, just about had a disaster there. Okay, so 0.225 amps, now that's appropriate. And then I finished up. I could have just been done, but I wanted to double check to make sure I did everything right. So I wanted to make sure that all of my currents really did add up to 0.1125, and they did. 0.9 plus 0.225 gives me 0.1125, so I knew that was correct. Hey, yay, I did it. Congratulations. So, there we go. Let's do one more just for good measure. Let's see if I can find it. There it is. Okay. So, go ahead and pause the video and see what you come up with. I'll be putting the answer up here in just a moment. Here's the table that I kind of set up if you want to just double check to make sure that that is right. And now I'll be putting up the final answer. Okay, and here is what I got for my answer. I got all of what you can see here. So I'll just walk you through how I got it. So first thing I did was I got my total resistance by doing this equation. You can see in orange down here. I did not just simply add these up. Once I got my fractions, I changed those into decimals. Something's going on here. Hold on. Okay, I just wrote something wrong. I didn't do any of the math wrong. Okay, so added these together and I got 0.5277 equals 1 over RP. Don't forget the 1 over part, 'cause that's what'll throw people off. Anyway, so then once I do the algebra, or if you know the shortcut, you end up with 1.895. Algebra would be multiplying both sides by RP, and then dividing both sides by 0.5277. Shortcut would just be doing 1 divided by 0.5277. And I get my 1.895. And once again, you'll notice that that total resistance is smaller than any of the other resistors in the circuit. Okay, So then I have two things. I know the total resistance and I know the total voltage. So then I can find the third thing, which is the current. So I take my 3 volts divided by the 1.895 and I get 1.583 amps. And that's good. So I'm just going to hold on to that to do my double check at the very end. And then I remember that in parallel circuits, all of the voltages are the same. So 3 volts to everybody. And then I now know the two things to find the third, so end up with 3 divided by 9 to get me 0.33333 forever, but I just gave you 4. 3 divided by 4, which is 0.75, and then 3 divided by 6, which is 0.5. And my double check tells me I did it right because I add all of those currents together and I end up with 1.583. So yay, I did it correct. And there's a smiley face because that's what I'm doing. So that's it. Thanks for listening.